Good morning, students. Today we have a presentation on compound microscope by Bibi. So I would first invite Bibi to give the presentation.
Assalamu alaikum everyone, and today I'm going to explain my compound microscope. Next teacher. This is a compound microscope you can see on the screen. Compound microscope is a microscope that have the ability to magnify very minute objects to substantial size, clearly showing the smallest details. A compound microscope has multiple lenses which collect light from the object and then focus the light into the eye. With the simple microscope also we can see, but with the simple microscope we cannot see the very minute objects, but this compound microscope we can see the very minute objects. These are the parts of the compound microscope: eyepiece, body tube, resolving nose piece, objective, condenser, mirror, base, and inclination joint, fine adjustment knob, coarse adjustment knob. The main three parts of the compound microscope is body tube, objective lens, and eyepiece. Next, then you can see these two are very important. These are two types of convex lens in compound microscope: objective lens and the eyepiece one. Next, then this objective lens, which is nearer to the object, is called objective. Its focal length and aperture are small. In eyepiece, the narrow tube is the eyepiece. In the figure, you can see the eyepiece is fitted in a drawn tube which can slide within the main tube of the microscope, and then distance can be between the two lenses can be changed. Its focal length and aperture are comparatively larger. This is a principle of compound microscope. Here in the figure you can see that O is the object and E is the eyepiece. Is the eyepiece, then a small object P and Q we can see here. It is kept outside of the focus FO of objective lens. A real and inverted, you can see the two lines are coming from P and Q. A real inverted and magnified image is P1 and Q1, you can see here. It is formed after the rays refracted in eyepiece. Now taking P1 and Q1 as object, the rays from P1 Q1 is refracted through the eyepiece lens. Now moving the eyepiece in such a way that P1 Q1 falls on the principal focus of eyepiece lens. The image formed when the rays are refracted from P1 Q1 is virtual. You can see here P1 Q1 is refracted and it is formed in a P1 Q1 to P1 P2 and Q2 as virtual image, and it is magnified and erect. This is a principle of compound microscope, and here it is a description I have written for you.
Have you finished, Bibi?
Yes, teacher, this much only.
Yeah, I think you can explain more on uh, this part.
Teacher, how much I understood, I explained to them.
Okay. So as she told, this is the objective and this is the eyepiece. Objective means the lens near which we keep the object, and eyepiece is the place near where we keep the eye. We keep our eye here. Now, the eyepiece usually have a larger focal length. See, F4 is the focal length of the objective. FE is the focal length of the eyepiece. So, usually FE will be larger than F4. So, the eyepiece have a larger focal length, and see the aperture of objective is small, while the aperture of eyepiece is large. Aperture means how much area which is open to the light rays. So uh, both the eyepiece have larger focal length and larger aperture. Now, when you keep the object, you have to make sure that the object is just before the focal length. Means it should be between FO, the focal length of the objective, and 2FO. So it should be kept in such a position. So when we saw yesterday the image formed by convex lens, when we keep a object between 2F and F, you will get a real inverted image. So to form the image, they have drawn a line, one which is parallel to the principal axis. You know, after refraction, it will pass through the principal focus of the objective FO, and another ray which we consider passing through the optic center will pass on straight. So the point where these two rays meet, you will get the image formed by the objective. That is P1Q1. P1Q1 is the image. You can see the image P1Q1, right? Is it erect or inverted? This is PQ.
Inverted.
It is inverted and it is real, right? Now this will act as the object for the eyepiece. And you can adjust the distance between the objective and eyepiece because they are fixed at the two ends of coaxial tube, and they can move between each other. There are two tubes which can move between each other. So you have to adjust the distance between objective and eyepiece in such a way that this image is between the optic center of the eyepiece and the focal length of the eyepiece. What will happen to the image if the object is kept between the focal length and the optic center, that is in front of the focal length? What will be the nature of the image formed? Yesterday we saw the image formed by convex lens, right? So if you keep the object between the principal focus and the optic center, what happens is you will get a magnified image which is virtual, because see, from this object we are considering three light rays. One which is passing through the optic center will pass on straight without any deviation. Another ray which is coming like this, after refraction, we know that when it comes out of the lens, it should bend towards the normal. So at this point, we consider the normal, it will be like that. Like this will be the normal. So it will bend towards the normal. Will these three rays meet? Will these three rays meet? No, because they are going diverging. So it will never meet. So when we see from here, we feel that these rays are coming from this point. So to get this point, we have to retrace this ray. We have to retrace this ray and this ray. So these three rays of light will meet at one point where we get our big magnified image. So compared to P1Q1, what about this image? Is it erect or inverted compared to P1Q1?
Erect.
Erect. Because P1Q1 is downward facing, P2Q2 is also downward facing. So we got a big magnified erect image of this object. But when we consider the main object, PQ, what about the final image? It is inverted, right? So when you consider the main object, the final image formed by a compound microscope together can be considered inverted. So this is how the image is formed. And when you see from here, we can see a very magnified and inverted image of the real object. Is it clear to you? Is it clear to you?
Yes, teacher.
Okay.